Charles Lyell, Principles of Geology. Chapter 1, Objects and Nature of Geology. Geology is the science which investigates the successive changes that have taken place in the organic and inorganic kingdoms of nature. It inquires into the causes of these changes and the influence which they have exerted in modifying the surface and external structure of our planet. By these researches into the state of the earth and its inhabitants at former periods, we acquire a more perfect knowledge of its present condition, and more comprehensive views concerning the laws now governing its animate and inanimate productions. When we study history, we obtain a more profound insight into human nature by instituting a comparison between the present and former states of society. We trace the long series of events which have gradually led to the actual posture of affairs, and by connecting effects with their causes, we are enabled to classify and retain into the memory a multitude of complicated relations, the various peculiarities of national character, the different degrees of moral and intellectual refinement, and numerous other circumstances which, without historical associations, would be uninteresting or imperfectly, or wildly distorted, understood. As the present condition of nations is the result of many antecedent changes, some extremely remote and others recent, some gradual, others sudden and violent, so the state of the natural world is the result of a long succession of events. And if we would enlarge our experience of the present economy of nature, we must investigate the effects of her operations in former epochs. That's former, not future. Well, and future as well. We'll get to discussing what all this means. We often discover with surprise, on looking back into the chronicles of nations, how the fortune of some battle has influenced the fate of millions of our contemporaries, when it has long been forgotten by the mass of the population. With this remote event, we may find inseparably connected the geographical boundaries of a great state, the language now spoken by the inhabitants, their peculiar manners, laws, and religious opinions, but far more astonishing and unexpected are the connections brought to light when we carry back our researches into the history of nature. The form of a coast, the configuration of the interior of a country, the existence and extent of lakes, valleys, and mountains can often be traced to the former prevalence of earthquakes and volcanoes in regions which have long been undisturbed. To these remote convulsions, the present fertility of some districts, the sterile character of others, the elevation of land above the sea, the climate, the various peculiarities, may be distinctly referred. On the other hand, many distinguishing features of the surface may often be ascribed to the operation of a remote era of slow and tranquil causes, to the gradual deposition of sediment in a lake or in the ocean, or to the prolific growth in the same of corals and testacea. To select another example, we find in certain localities subterranean deposits of coal, consisting of vegetable matter, formerly drifted into seas and lakes. These seas and lakes have since been filled up. The lands whereon the forests grew have disappeared or changed their form. The rivers and currents which floated the vegetable masses can no longer be traced. Well, actually they can, but this was written a while ago. And the plants belong to species which, for ages, have passed away from the surface of our planet. Yet the commercial prosperity and numerical strength of a nation may now be mainly dependent on the local distribution of fuel determined by the ancient state of things. Geology is intimately related to almost all the physical sciences, as is history to the moral. A historian should, if possible, be at once profoundly acquainted with ethics, politics, jurisprudence, the military act, theology, in a word, with all branches of knowledge, whereby any insight into human affairs or into the moral and intellectual nature of man can be obtained. It would be no less desirable than a geologist should be well versed in chemistry, natural philosophy, mineralogy, zoology, comparative anatomy, botany, in short, in every science related to organic and inorganic nature. With these accomplishments, the historian and the geologist would rarely fail to draw correct and philosophical conclusions from the various monuments transmitted to them of former occurrences. Easier said than done, but yeah. They would know to what combination of causes analogous effects were referable, and they would often be enabled to supply by inference information concerning many events unrecorded in the defective archives of former ages. But the brief duration of human life and our limited powers are so far from permitting us to aspire to such extensive acquisitions that excellence, even in one department, is within the reach of few, and those individuals most effectually promote the general progress who concentrate their thoughts on a limited portion of the field of inquiry, as it is necessary that the historian and the cultivators of moral or political science should reciprocally aid each other, so the geologist and those who study natural history or physics stand in equal need of mutual assistance. A comparative anatomist may derive some accession of knowledge from the bare inspection of the remains of an extinct quadruped, but the relic throws much greater light upon his own science when he is informed to what relative era it belonged, what plants and animals were its contemporaries, in what degree of latitude it once existed, and other historical details. A fossil shell may interest a conchologist. Interesting, never heard that term before. Though he may be ignorant of the locality from which it came, but it will be of more value when he learns with what other species it was associated, whether they were marine or freshwater, whether the strata containing them were at a certain elevation above the sea, and what relative position they held in regard to other groups of strata, with many other particulars determinable by an experienced geologist alone. On the other hand, the skill of the comparative anatomist and conchologist are often indispensable to those engaged in geological research, although it will rarely happen that the geologist will himself combine these different qualifications in his own person. Some remains of former organic beings, like the ancient temple, statue, or picture, may have both their intrinsic and historical value, while there are others which can never be expected to attract attention for their own sake. A painter, sculptor, or architect would often neglect many curious relics of antiquity as devoid of beauty and uninstructive with relation to their own art, however illustrative of the progress of refinement in some ancient nation. It has therefore been found desirable that the antiquary should unite his labors to those of the historian, and similar cooperation has become necessary in geology. The field of inquiry in living nature being inexhaustible, the zoologist and botanist can rarely be induced to sacrifice time in exploring the imperfect remains of lost species of animals and plants, while those still existing afford constant matter of novelty. They must entertain a desire of promoting geology by such investigations, and some knowledge of its objects must guide and direct their studies. According to the different opportunities, tastes, and talents of individuals, they may employ themselves in collecting particular kinds of minerals, rocks, or organic remains, and these, when well examined and explained, afford data to the geologist as do coins, medals, and inscriptions to the historian. It was long ere the distinct nature and legitimate objects of geology were fully recognized, and it was at first confounded with many other branches of inquiry, just as the limits of history, poetry, and mythology were ill-defined in the infancy of civilization. Werner appears to have regarded geology as little other than a subordinate department of mineralogy, and Desmarest included it under the head of physical geography. But the identification of its objects with those of cosmogony has been the most common and serious source of confusion. The first to endeavor to draw a clear line of demarcation between these distinct departments was Hutton, who declared that geology was in no ways concerned with questions as to the origin of things. Okay. But his doctrine on this head was vehemently opposed at first, and although it has gradually gained ground and will ultimately prevail, it is yet far from being established. We shall attempt this in the sequel of work to demonstrate that geology differs as widely from cosmogony as speculations concerning the creation of man differ from history. But before we enter more at large on this controverted question, we shall endeavor to trace the progress of opinion on this topic from the earliest stages to the commencement of the present century. So that was chapter 1. This is all very long and detailed compared to the actual simplicity of the base idea that it's introducing, and while far from the worst of its genre or century, it is somewhat tedious. All Lyell was really saying here in this first chapter is that in order to understand how things came to be what they are, whether in dealing with human events or the natural geological, biological world, it's all simply the most recent consequence of a series of events that came before. The idea, the argument, and today the accepted law of nature, that the basic processes and events that shaped the Earth in the past are the exact same ones shaping it and current events today. Again, whether you're talking about human history or natural history. Sediment accumulation, rock formation, volcanic activity, the water cycle, and so on, these processes don't work any differently today than they did in the prehistoric past. The continents may drift and change shape, and they do. Ice may advance and recede. Lakes fill up with sediment, and whole island chains erode, submerge. The mountain ranges we know of today may not be the same ones that were around 500 million years ago, and they're not. Yet the world has not, and will not, suddenly change how it works fundamentally. It may surface and play out in slightly different ways depending on the precise factors involved, but the basic nature of what is at work remains the same. Now, I threw in a few little remarks as I was reading. I try not to do that, but the urge is just a little too strong at times. I actually have never encountered the term conchologist before. It refers to the study of mollusk shells. It comes from the ancient word konkos, ancient Greek word, which gave us the terms cockle and conch shells. Cockle and conch shells both refers to the shells of certain mollusks. Anyway, the chapter says that an artifact of any science or history can be best understood and most valued when its meaning is compared and cross-referenced and cross-examined across all fields that it has or had some overlap with. And geology, the revelations and explanations that geology gives us, provides the foundation for so many of the earth sciences and of archaeology itself. Digging through soil and rock layers to trace the events of human history is carried out almost exactly like digging through rock layers to find Mesozoic or Paleozoic creatures. All living things are affected by the planet they live on and what changes it goes through. There is a trope in stories known as the omnidisciplinary scientist. The scientist character who has knowledge of all fields almost equally, depending on what the character specializes in. But I mean, you've seen this kind of character. Can explain any topic in history, biology, anatomy, physics, chemistry, geology, astronomy, forensics. Knowledgeable about everything. Which is what Sheldon Cooper from The Big Bang Theory thinks he is. He actually sucks at it outside of theoretical physics. Not to mention the show's characters like to make relentless fun of geology. Little do they understand that geology is absolutely foundational to all of the branches of earth science. Without geology, there'd be no paleontology. At least, no actual competent paleontology. And as such, no reasonable depictions of dinosaurs, no advancement in knowledge, because you would have very little information on how the geological process work, where fossils can be found and where they can't be found, where fossils of what times periods can't be found, why they're so rare. There'd be no understanding of plate tectonics, which explains so much of how the Earth works. It really is fundamental to any even remotely realistic attempt to address preserving the future of the planet. In the next chapter, we will start getting into some of the very basic foundational rules of the study of geology. And by extension, all of the earth sciences.